This lesson is about congruent triangles, and we're going to learn 3 postulates for proving triangles congruent. One important thing before we get to proving triangles congruent is to be able to talk about the parts of triangles in terms of their relative positions. So we're going to use the words opposite and included a lot. So when I say talk about side AB and its relationship to angle C, I notice that AB is across from angle C. So I say AB is opposite, side AB is opposite angle C. And likewise, angle C is across from side AB. So angle C is opposite side AB. Okay, now the other thing is what is angle C between? And I look, and angle C is between, this angle is between side BC and side AC. So I use the word included. It's included between, it's in the middle of the two sides. The sides of that angle are formed by those two sides of the triangle. And then likewise, AB, side AB, if I look at where side AB is, it's included between angle A and angle B. So again, using that word included can refer to an included side or an included angle. Okay, so we'll be using the words opposite and included a lot. Okay, the first postulate is this. If all 3 sides of one triangle are congruent to all 3 sides of a second triangle, then the 2 triangles are congruent. And we call that the side-side-side postulate. And we abbreviate it SSS. The triangles are congruent by side-side-side postulate. The second postulate is that if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the 2 triangles are congruent. And we call this side-angle-side. So 2 triangles can be congruent by the side-angle-side postulate. A third way to prove the 2 triangles are congruent if 2 angles and the included side of one triangle are congruent to the 2 angles and included side of another triangle, then the triangles are congruent. And they are congruent by the angle-side-angle postulate. Okay, so here's for a few examples. A first example, we have a triangle with looks like possibly a bisector down the middle of it, but just a segment BD down the middle of it. And we're told that B is the midpoint of AC and AD is congruent to CD. So let's mark up the figure and see what we've got. Point B, if that's the midpoint of AC, it means that this segment AB is congruent to segment BC. The second thing we're given is that segment AD is congruent to segment CD. Okay, now the last thing that we can do is we can recognize that both triangle ABD and triangle CBD share a common side right down the middle, that is segment BD. So I can put in, well, that segment BD is congruent to itself, sort of reflexive property. These are the 3 pieces of information, that I would need to be able to do a proof. So I've got 3 sides congruent, and one triangle congruent to 3 sides of the other triangle. So I could say now that I've proved or shown that triangle ABD is congruent to triangle. Now I'm going to match up. The A is across from the middle segment BD, angle A. So I'm going to start with the one in the other triangle across from that, and that would be angle C. And if I go to B next, I will be going to, on the first triangle, I'll be listing B next in the second triangle. And then I go down to D in both triangles. So I can say that ABD is congruent to CBD by the side-side-side postulate. All right, in this next example, I have a figure, a four-sided figure, but it's divided into two triangular pieces, and I'm given that segment AD is parallel to segment BC. So if I mark these two segments as parallel, I have to investigate whenever I'm told that segments are parallel, what angles does this mean are congruent to each other. And if I trace this angle right here, triangle ADB, I can see that it would be then congruent to triangle CBD down here, because BD is like the transversal. So those are alternate interior angles congruent. I'm also told that AD is congruent to BC, so this segment is congruent to this segment. Now, the third piece of information I need is what I can see is that this segment in the middle, BD, is common to both triangles. And, you know, if I was listing this in a proof, this would be my side that I needed to prove. I would say BD is congruent to itself using reflexive property. So now I have the two triangles congruent. I can say triangle ADB is congruent to, now A is across from the common side, so I would pick up C will go with A, angle C will go with A. And then if I've moved from angle A to D when I'm listing ADB, that's the angle that's the congruent to the alternate interior angle where B is. And then lastly I go to the unmarked angle in each, so this would be a D. And this is by the postulate of side angle side, because I have an included angle which is angle D and angle B between two congruent sides. So that's side angle side. Okay, in this last example I have two triangles, and I'm told that side AB and side DE are both perpendicular, those segments, to segment BD. So I've already got those marked as right angles, and we can see that if they're both right angles that they must be congruent to each other. Then I have that segment AE bisects segment BD. So that means that BD has been bisected, so that this piece, if C is the midpoint, C would be the midpoint. So this segment here, BC, is congruent to segment CD. And that's what I can tell from that. And then lastly, I can see that I have a pair of vertical angles here in the middle that are congruent to each other. So I can add that angle ACB is congruent to angle ECD. And if I was doing a proof of this, I would have the three parts that I needed, the corresponding parts congruent. So I would be able to say that triangle ABC is congruent to triangle. Now A is going to, across from the vertical angles, or opposite, not across from the vertical angles, it's the non-right angle in the triangle. So A goes with angle E, and the two right angles B and D go together, those correspond, and then C corresponds in both. So triangle ABC is congruent to triangle EDC by the angle side angle postulate, because two angles and an included side of one triangle are congruent to two angles and the included side of another triangle. And that's it on congruent triangles.